Welcome to Data Science using Python. In this video, we're going to be looking at regression and assessing the normality of the residuals. Remember, that's one of the assumptions, is the normality of the residuals, not the normality of the data. Now, I'm going to use the same code that we've been using as we've been going along if you've been following the videos. And if we do look here, we can clearly see that we uncommented this SciPy stats again. We used this previously, and we're going to use it again today. So make sure it's uncommented, because it's probably already in your code. All right, so we're going to run all of this because we have, just to make sure everything runs, this is our fitted model down here. The CT1 res has all the information we want on it. So what we want to do is create a QQ plot. Okay, and a QQ plot is not a test for normality. It is not a test, and it's an assessment, but it's not a test. A test has a p-value on the end. So if you're asked to create a test for normality, guess what? This is not one of them. All right, so let's put in here resid. This is how we get the residuals out. We want it to fit, and we're going to put here true. And the reason we want to do this is so that it lines up. Usually the normality that it uses is 0, 1, and we need to adjust it to reflect the variance that's associated with the residuals. And then here we're going to have a line at 45. And if I run this, here I'll give you a pause for a second. Here's the residuals. We want to fit it, yes, and we want the line at 45. Okay, so if I run this, this is the picture I get. So here you can see here my dots along it, and there's a straight line, and that's how you read a QQ plot, is how well does the residuals follow along this line. Are they a straight line, a straight 45 line? If they are, then it's more than likely that your residuals are at least approximately normal. So what we can do now is an actual test. So let's look at a test for normality, which we're going to look specifically at the Shapiro-Wilks test. So let me scroll down here to give you some more to look at. So here, H naught is the residuals are normally distributed versus HA, the residuals are not normally distributed. Okay, we need a significance level. You want to remember, you don't want to reject here. So I'm going to put it pretty high. Okay. No, maybe I'll make it really, really small, actually, because I don't want to reject. Okay, and then here, our test statistic is going to be the... Come up here, get this, come down here. That way people know exactly where you got it from. And the function we're going to use is Shapiro. And then our decision rule is if the p-value that we get out of this thing is less than alpha, reject H naught. Okay, and yes, I'm going through all of this stuff again, being quite pedantic about it on purpose, because I want you to understand that there's a whole thing that's going on here whenever you do a hypothesis test. Okay, so let's actually do this, Shapiro, and then just put in our residual CT1 underscore res dot resid. Okay, that's the residuals from our fitted model up here. And we can run this really quick, and we will see that we get the test statistic and the p-value. Okay, so it comes up with a test statistic, which we don't really care about. Well, we do care about the p-value in this case, and we're going to comment this out, right, because it's in the comment. And I'm just going to copy and paste several digits over. Here's the p-value associated with it. So our decision is, since the p-value is equal to the number we just had, which is clearly bigger than 0.00432, which is our alpha, we fail to reject H naught. Okay? And our conclusion is we have insufficient evidence to claim that the residuals for our regression model are not normally distributed. And this is the thing where most people get confused. They always want to reject. I need to reject something. I'm doing a hypothesis test. I need to reject. No, you don't. This time you don't want to reject. All right, there's also another test that you might want to do. So the Kolmogorov-Smirnov test is another test for normality, and I'll show you how to do that real quick. I'm not going to go through the whole list, but basically you just swap this out wherever you use the other code. So this would be STKS test. You're going to put in here CT1 underscore res dot residual. And then here we're going to put in norm because it's going to check it against the normal distribution. And if I run this one real quick, you will see that I get the test statistic and a p-value here. And notice this p-value is really small. So just keep that in mind when you do this. This one's really small. Is it smaller than our rejection? Yes, it is. So in this case, we would actually reject. And that's generally the problem with Kolmogorov-Smirnov is it's super sensitive. Once you get a reasonable amount of data, it always rejects. So don't worry about it. There's also the Anderson-Darling, which I'm not going to show you just because we're running short on time. You can always look it up and run it on your own. All right, so in the next video, we're going to look at constants or the constant variance assumption. And I will see you there.